This is problem 16 of chapter 11 of Giancoli 6th edition. So they give us the mass of an object. So they give us the mass, and they also give us the equation that this mass is vibration. They also give us the equation for this vibration. So in my case, this equation is the following. Is 0.40 multiplied by the cosine of 8.43 multiplied by the time. Okay, and in my case, the mass is 0.46 kilogram. Very well, then comes the first question. What is the amplitude? Well, the amplitude is given immediately in the equation. This is the amplitude. So we are done with part A automatically with the equation. Determine the frequency. That's part B. Well, the frequency, we know that this whole part here is 2 pi frequency, right? This whole part here is the angular velocity. So we can get the frequency also. Then comes the next question. Determine the total energy. The total energy, well, I can use, for example, the total mechanical energy, I can use, for example, 1/2 of mv max squared. Well, then you may get worried that you don't see Vmax explicitly appearing, but remember that Vmax, when we use that analogy with the uniform circular motion, we know that Vmax is 2 pi of amplitude divided by the period, which we can also write as 2 pi frequency multiplied by the amplitude. Well, from the equation, we do have this 2 pi frequency. We just wrote it here in part B, right? So we do have this 2 pi frequency, and we do have the amplitude. So yes, we do have the maximum speed. And the problem also gave us the mass. So yes, we have all the ingredients to find the total energy using the maximum kinetic energy. Next question is, part D is, what is the kinetic energy and the elastic potential energy? So let's call it Ke here to differentiate from the spring constant, right? And what is the elastic potential energy? At a certain intermediate point, in my problem here, they are saying at position 0.34 meters. Okay, before going into the kinetic energy, let me go straight to the elastic potential energy, right? The elastic potential energy is very easy to compute. It is just 1/2 of kx squared, and x is given to us. X is given to us, but you may worry that k is not given to us. Well, is that right? What are the equations that we have that can connect k with information that we have here? Look, we have the frequency, right? We also have the mass, so we can find k. How? Remember that we have an equation that connects the period with 2 pi square root of mk, right? So from here, I can find k because I have the frequency, so I have the period, and the mass is given to us. So how would we find k from this equation? Well, we have here, let me write this as 1 over frequency is equal to 2 pi square root of mk. Let me play a little bit more. What I have here is that square root of k over m, I'm passing this whole thing to the left, is equal to 2 pi frequency. So this whole number we have from the equation that was given to us, the mass we have, so we can find k. So in other words, k is mass multiplied by this 2 pi frequency squared. All right? So we do have the potential energy because we do have k and we do have x. X is given to us. All right, So from here, we can find the elastic potential energy. Now, if we go for the kinetic energy, well, you may go straight. You can use this equation, 1/2 of mv squared. For that, you will have to find v at that displacement point 34 and then find the kinetic energy. But there is an easier way. We just found this potential energy, okay, at this intermediate point. And in the previous question, C, we had found the total energy. So we know that the total energy, I'll call it here the total mechanical energy, is equal to 1/2 of mv squared, so the kinetic energy that we are after at that intermediate point, plus 1/2 of kx squared, which is the potential energy that we just found. So you see, the kinetic energy is just that energy that we found in question C minus the potential energy that we just found. Okay, so this is easier than going to find the speed at this intermediate point. But you see, there are two ways to find this kinetic energy. You can do both and check if they agree.